In the last example for this lesson, we're going to work with plotting an inequality that's given to us in a form that's not slope-intercept form. Rather, we're going to work with standard form in this example. Remember that the standard form of a linear equation takes the expression ax plus by equals c. So we're going to look at a standard form linear inequality that has this general form. So our inequality for this example is 2/3 x minus 1/2 y is greater than 4. We're going to take a little different approach in dealing with this inequality because it doesn't lend itself well to plotting a y-intercept and using the slope unless we manipulate it and get it in a different form. So what I'm going to do is I'm going to use a different approach, and something that I want you to remember from our recent work is that when we're given an equation or inequality in standard form, it's pretty simple to plot the x and y intercepts. So that's the approach we're going to use here. We're going to plot x and y intercepts and use those 2 points to graph the inequality. All right. So let's start with the y-intercept for this particular inequality. What I'm going to do is use my finger and I'm going to cover the part of our expression on the left of the inequality that includes x variable and its coefficient, and I'm left with negative 1/2 y is greater than 4. So if I solve this inequality, you'll notice that what I need to do is multiply both sides by the inverse of negative 1/2, which would be negative 2. So if I multiply both sides of the inequality by negative 2, the result is y is less than a negative 8. So our y-intercept in this case is going to be negative 8. 1, 2, 3, 4, 5, 6, 7, 8. There's our y-intercept. Perhaps I should write that solution process down so that you have an example of how that was done. So negative 1/2 y is greater than 4. I'm going to multiply both sides of this inequality by the multiplicative inverse of negative 1/2, which is negative 2. So we have negative 2 over 1 times negative 1/2 y is greater than 4 times negative 2 over 1, or negative 2. Notice that a negative 2 times a negative 1/2 is 1, and so that leaves with us 1 y is greater than 4 times negative 2 is negative 8. So there's our y-intercept, and that's how I got that value. We're going to do exactly the same process with the x term. We're going to use our finger and cover the y term, and the resulting inequality is 2/3 x is greater than 4. I'm going to write that down here too, or as well. X is greater than 4. And then we're going to solve this inequality. To do that, we're going to multiply both sides by the multiplicative inverse of 2/3, and that's 3/2, times 2/3 x is greater than 4 times that same 3/2. So notice that 3/2 times 2/3 is 1, and 1x is just x, is greater than 4 times 3 is 12, divided by 2 is 6, so x is greater than 6. our x-intercept is 6. So 1, 2, 3, 4, 5, 6. So by doing that process of covering one of the variable terms and solving for the other in the inequality, I was able to find the x and y intercepts. And now we're going to connect the x and y intercept with a line. Notice that our inequality symbol does not include the equal part, so we're going to use a dashed line again. So we'll use a dashed line to connect those 2 points. So this line forms our boundary condition. And notice that any ordered pair that's on the line will not be included in our solution set. We don't know which half plane is the solution set though, so we'll substitute again 0, 0 into our original inequality and see if we get a true statement. If we do, that side of our half plane will be the solution side. If not, the other side will be a solution side. So let's substitute 0, 0 into that original inequality. We get 2/3 times 0 minus 1/2 times 0. Is that greater than 4? So is 0 greater than 4? The answer is no. So the opposite side, the side opposite where the point 0, 0 is located, will be our solution set. So we're going to shade all of the plane, the half plane, below our boundary line, and that will be the solution set to this inequality. If you want to check, you can substitute either a shaded ordered pair, an ordered pair that's included in the shaded region, or an ordered pair that's shaded in the, or it's included in the non-shaded region, and verify that the solution is correct. So here we have the graph of a standard form equation that we got by graphing the x and y intercepts, and then connecting those with appropriate boundary condition line, and then shading the half plane that was included in a check of 0, 0. Notice 0, 0 was not included, so we shaded the opposite side of our boundary condition line.